3.9 is kind of nice because this goes back to something that's pretty old from stuff that we didn't cover this semester so far, and stuff from like chapters 1 and 2 out of the book, and that is tangent lines. And so we're going to kind of review on that a little bit, refocus on that, and then talk about its relationship, or like a tangent line's relationship to the curve that it's tangent to. So up there I put a little fill in the blank. Tangent line is a good approximation for values that are close to the point of blank. Tangency, not doink, although that's a good guess. There we go. So point of tangency, of course, is the place where the tangent line intersects the curve that it is tangent to. So, of course, this word is a relative word, close. Like, what do you mean by close? Close to you might not be close to me, and vice versa. And so, we can talk about that a little bit. We're going to talk about that a lot more this year. Believe it or not, so let me just give you a brief look forward here. We did a ton of stuff with tangent lines in AB, and I'm assuming that you got pretty decent at that. In our class, we'll obviously do some work with tangent lines, but later on, I'm misnaming this thing, but later on we're going to kind of look at tangent curves. It makes sense? Instead of a tangent line, it's almost going to be sort of a tangent curve concept. That'll be something we do in the second semester. So anyways, we're doing tangent lines right now. So for this function right here, f of x equals root x. Please find the equation of the tangent line at 2, root 2. So this is the point of tangency. And since you've got the point of tangency, the only thing you really need to work to do here is find the slope of the tangent line. So I'm going to let you do that. Try to find the slope of the tangent line and put it together to find the equation of the tangent line. I think you can do this without a calculator too. Ready, go.
Is part B of this calculated actively?
I don't think it needs to be. I think your answer might not be totally satisfying, but I think you can certainly calculate it, at least find a representation of it. Okay, so to find the equation of the tangent line, the only other piece of information I really need is that slope. Slope of the tangent line, I might as well just be saying what? Derivative, yeah, dy dx, or f prime of x. So f prime of x is equal to 1/2 x to the negative 1/2. And at my point of tangency, of course, what that is, that's the slope at any point on this curve. I don't really care about the slope at any point. I want to know the slope specifically at my point of tangency. So how do I turn this into my slope at my point of tangency? Plug in the 2. Plug in the input. Yep, so f prime of 2 is equal to 1/2 times 2 to the negative 1/2, which is the same thing as 1 over 2 root 2. So then as far as how I finish this, I am a fan, as most of you know, of point-slope form, simply because point-slope is plug, 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 done. You don't even really have to do any arithmetic to finish it. So I would write for my tangent line, it would be y minus the square root of 2 is equal to 1 over 2 root 2 times x minus 2. Make sense? Any questions? So yes, this is like Algebra 1, right? As soon as you know the slope, it's just like, can you put it together? Not too bad. Okay, part B says approximate f of 1.8 using the equation of the tangent line. I thought I'd draw you a little picture here just to make sure you understand what's actually happening with this. Here is the y, there is the x axis, and y equals root x is this lovely blue graph right about there. And the tangent line that I've drawn is at 2, root 2. So in red, this would be my tangent line, something like that. Make sense? So what this is asking me to do, sometimes B can be kind of confusing. The word approximate, we're not used to that in math, right? I mean, how many times, before you took a calculus course, did it say approximate this or approximate that? I really think about that. In pre-calc, wasn't it more or less find the answer? In algebra 2, use the unit circle to find the answer. Nowhere do they really say estimate or approximate this or that. Maybe a little bit, but not too much. We do it a lot in here. So approximate the value of f of 1.8 using the tangent line. So earlier I said that around the point of tangency, the tangent line is actually a pretty good approximator of the curve. Do you see how that's true? If I'm like right in here, they coincide fairly well, don't they? But if I get outside of that area that's close, if I get out to the far left or far right edge, the approximation would get worse and worse. And so 1.8 is pretty close to 2, depending on your definition of close. And so the way I would do this is I would say that y minus root 2 is equal to 1 over 2 root 2 times 1.8 minus 2. What I've done is I've plugged a 1.8 in for the line's input, and I'm going to then use that to approximate the curve's output. So I think this is actually pretty doable. Y minus root 2 equals 1 over 2 root 2 times negative 0.2 or negative 2/10. So y minus root 2 would equal, negative 1 over 2 root 10. Or, sorry, 10 root 2. And you just add it over. So it'd be y is equal to negative 1 over 10 root 2 plus root 2. And I'll say that's approximately equal to f of 1.8. Sorry, that kind of got a little squeezed there. I'm not really that concerned about the arithmetic. Maybe that's a little bit on the out there side as far as what I would expect you to do in the middle of a quiz or a test, but yeah. So then the other piece is this. I would like to know what's the relationship of my approximation to the actual value. So is the approximation that I just figured out, is it too high or too low? I know that it's off, right? Let's review this. At that point of tangency, right there, you guys remember that right there, I'll put it like this, the xy for the curve is exactly the same as xy for the line, right? Isn't that what an intersection point is? So right there, the 2 points are equal. What else is the same? The slope, yeah. So slope of the curve is exactly the same as slope of the line. That's all true at the point of tangency, but isn't that probably going to be false almost anywhere else? So the minute you move off that point of tangency, you know that you're off. This question is dealing with, well, are you off by being too high or too low? So just looking at the graph, can the graph tell you what you need to know? What does the graph tell you? My approximation is too high. Yep. So I agree completely with the too high conclusion. So we could circle that, but it does ask this painful question here, why? Or justify yourself or give a reason for your answer. And if your reason is, hey, I looked at the graph and it was obvious, not very good reason, right? Because, we could look at all kinds of graphs depending on how far zoomed in or out you are. We could all be fooled by what it is, right? So a graph is not always the greatest representation to base like a rigorous justification on and say, well, this is for sure true. Here's how we do this. We have to use the second derivative to do this. So I'm going to find my second derivative first. The second derivative would be f double prime of x is equal to negative 1/4 x to the negative 3/2 using the power rule. And I got to decide, is f double prime going to be positive or negative on the interval that I'm concerned about, and then I can use that reasoning. I use that to give my reasoning some momentum, some weight. So let's think about this. This one is kind of interesting. The next one we'll look at is a little bit tougher. This is kind of interesting though, because when you think about x's, like what kind of x's could you plug in for that x? What kind of numbers? Say again? 2. What else? 1.8. What else could you plug in? I'm just talking about in general. What numbers could you plug in for x? Anything 0 or above, right? Anything 0 or above. Why can't you plug negatives in? Square root, yeah, square root of a negative. That's not going to work. So here's what you got to do. We had 2 points that were really crucial here. We had this, I'll just highlight it. We had the point of tangency, and we had this point that we approximated when x equals 1.8. We have to show that f double prime is always positive or always negative on that interval from 1.8 to 2. It's not just about 1.8. It's not just about 2. It's got to be the whole interval. We can talk about why that is here in a second. So I'm going to use some really specific wording. And we can talk about why you have to use this sort of wording. What I can say is this. F double prime of x is going to always be negative for x greater than or equal to 0. The reasoning on that is, no matter what I plug in, whether it's 0, bless you, whether it is 0, 1, 2, 3, 4, 5, whatever I plug in, any one of those valid domain members, when I do the square root of it, that's going to make it still be positive. And I take it to the third power, it's still positive. I flip it down to the denominator, it's still positive. So this, no matter what I plug in, other than 0, no matter what I plug in for this, won't I get an output of positive times this negative will always give me a negative, won't it? That's kind of the reasoning there. So f double prime is going to be always negative as long as we're plugging in actual domain values. Therefore, f double prime of x is negative on the interval from 1.8 to 2 on that interval. Therefore, the approximation is too high. If you wanted to throw in one more piece of logic there, you could say, yeah, therefore f is concave down. Just be really careful if you say f double prime is negative, therefore concave down. I know we talked about that earlier. Listen to what I just said real carefully. If f double prime is negative, therefore concave down, then we have to ask, well, what is concave down? And so if you're going to say that, no problem. Just make sure you're telling us what is concave down or concave up or whatever. The other piece is this. You have to mention the interval that contains both the point of tangency and the number that we approximated. It can't just be one or the other endpoint. It's got to be the whole interval that you bring into your argument. Because on that interval, how many times could the concavity of f change? Yeah, lots of times, right? Infinitely many, or approaching infinity, whatever. I mean, it could change billions of times, whatever it is, and that would affect our answer. So I want to make sure that you bring in the whole interval type argument. Okay. So I think we have another question kind of like that one, but before we move on, do you have any questions? Okay, cool. All right. So this one a little bit different. If g of x is equal to sine of 2x, and immediately, you know what you should be thinking about? Think about the concavity argument we just made. Doesn't sine just do this the whole time? Doesn't it go from concave up to concave down like over and over and over again? It's very different than that last one we did, right? That one was concave down the whole time. This one is going to be changing concavity a lot, right? And so that's going to make a little bit of a difference on how we approach it. But I think A and B are really the same kind of question as before. So take a minute, see if you could work through those, and just think of it as a little bit of practice here. Work on A and B. And think of this as an opportunity to practice your unit circle skills.
Unit circle skills?
I'm really sorry to use that kind of language here at school, but you know, I'm sorry, it just slipped out. Unit circle, sorry. Anyways, yeah. See if you can do at least do A without a calculator. I hope that you can. I think B. I mean, you could write an expression for it, but it'd be nice to just have it simple, right? Yeah. I'm okay with that. Hey, Liz, I assume you like your Apple Pencil.
This actually is mine. I took it from the graphic design room in exchange for my Denver Arts Museum's membership card.
Oh, so like, it was like your rental.
Yeah.
Well, you like it, you like these.
Oh, I should have given him my Topgolf card.
He's like, that's what I should just collect.
Well, because I was gonna, he's like, I just need something with his name on it, so I know who to yell at if it goes missing. And then like, this has my mom's name on it, like, you'll get the point. And he's like, Kathleen, taking my supplements. I'll let you.
Okay, just working on A and B. Got it?
Yes, sir.
So you guys argue sometimes?
Yes.
No. I know you.
Nah.
Well, you argued about the whole guy in the ocean
Well,
and the
half
shore.
the time we have the same answer.
I'm sure. I'm sure. I could just like sense. It's like a healthy animosity, right?
Yeah.
It seems like it to me. If they ever start like punching, what? Say again? What's that?
I kind of kept my distance from
Oh,
the person and stuff.
Gotcha. You just didn't want to get caught in the crossfire. Okay. Things start flying.
Can we use the calculator for B?
I think that's pretty reasonable. I mean, you could come up with an expression for it, but it'd be
Just like the exact answer.
yeah.
Can you do B without a calculator, or should I?
So you could come up with an expression for it, but I think it'd be pretty reasonable to just okay, let's do a little adding and subtracting, multiplying on the calculator. I think that's pretty reasonable. I just wanted you to do a little practice with the unit circle. Okay. Jaden, so this is more fresh in your mind perhaps because we just did a bunch of tangent line stuff not that long ago.
This is like, oh, I can do this.
You can do this. You don't need anybody's help. Maybe you could help somebody else. Colin might not need any help though. Uh-oh.
Triangle. I was trying to.
No good.
I didn't want to do that. That's single
All right. Let's see how this goes. We've got our point of tangency right there already. So that's been just given to us like so. So the only thing we really have to do a little bit of work to find is the slope of the tangent line. Slope of the tangent line would be g prime. What is g prime of x? And so she used the chain rule correctly there, 2 cosine of 2x, so that's great. And let's keep in mind, there was always, seemed like there was somebody last year, I'm not saying anybody necessarily in this room, but there was always somebody that thought that was the slope of the tangent line. That right there, that's the slope of the tangent line at any point. We don't want the slope of the tangent line at any point. We want to know the slope of the tangent line at our point of tangency. So you always got to take it that one step further and plug in whatever the input requires. In this case, it's just an x value. So we'd say g prime of 5 pi over 8 is equal to 2 cosine of, the 2 and the 8 would cancel to give you 5 pi over 4. You'd use your unit circle and find out that g prime of 5 pi over 8 is equal to 2 times what? Root 2 over 2?
Negative.
Negative root 2 over 2. There you go. So negative root 2 over 2. So I don't know where you stand with the unit circle. I don't know if doing something like that was challenging or if it was easy or somewhere between. Maybe you're just rusty. As you might well guess, we're not going to take a whole day and review the unit circle. So trusting that you will do what you need to do so that if you see stuff like that, you'll be okay. Anyways, you know yourself. You know what you need to do. The 2's would cancel out, giving you negative root 2 for the slope of the tangent line. So our equation of the tangent line would be y minus negative root 2 over 2 equals negative root 2 times x minus 5 pi over 8. One word of caution here. I know this has been true at the reading. It used to be when you're actually doing your AP test, if it asked what is the slope of the tangent line, and you give the whole equation of the tangent line, used to be that they would say, they gave the right slope, we'll give them full credit. They've kind of gone away from that in recent years, the last couple of years. If they ask for the slope of the tangent line and you give the entire equation of the tangent line, they're going to be like, we don't know if they really know what they're talking about because they didn't give us the slope. They gave us the whole equation. Do they really understand? Maybe they do, maybe they don't. We don't know, and so they would usually not award full points. So just be really careful that you read it. Maybe mark the question up and circle the word slope or circle the word equation, whatever it is, and make a big deal about it so maybe you'll have a better chance to remember. Okay, so then B, were there questions on A? Sorry. Okay, B, if we are going to try to approximate, I would say y plus root 2 over 2 equals negative root 2, and then we're going to go 2.1 minus 5 pi over 8 in there. And a number of you said, hey, could we just use the calculator for this? I think that's really reasonable. You could obviously get an exact answer for this, but it's going to be awkward, maybe not worth it. I don't know. So if you do that, you get y equals what? Can you have a decimal answer for this? 0.9002. Okay. So that's what the y value on the line would be. And so we're going to say, well, then that is approximately equal to g of 2.1. Some notation like that would be good. Please don't abuse the equal sign. If two things really aren't equal, don't tell me that they're equal. You can do the little squiggly approximate stuff. I think that's fine. But don't say that they're equal, because they're really not. Okay, this is a little bit tougher. Is the approximation too high or too low? Remember what we are concerned about. We are concerned about the interval from 5 pi over 8 to 2.1. Which of those is bigger? You guys figure that out yet? 5 pi over 8 to 2.1 is bigger? Okay, so 5 pi over 8 to 2.1, that is what we're concerned about. And from a conceptual standpoint, the questions would always be written in such a way that you can't say, well, hey, I used my calculator and I figured out what g of 2.1 is, and it's less than or greater than, or what. You can't, it's going to be written in such a way that you can't. Like the calculator just wouldn't be active, or you'd be given other types of information. But this is the interval that we are concerned about. We still got to deal with g double prime. We still got to deal with concavity, essentially. So let's figure out what g double prime is. What would g double prime be? Negative 4 sine of 2x. And as you know, since this is originally this is a sine graph, isn't g double prime going to go from positive to negative repeatedly? Right? And so I need to figure out on the interval that I care about, is g double prime positive or is g double prime negative? And in order to do that, what might be a good first step to do with this? If I want to find out where g double prime is positive or negative, set this equal to 0, right? Because isn't that what divides a continuous function between positives and negatives? So if I set this equal to 0, there's more unit circle loveliness waiting for you. Divide by negative 4. Sine of 2x is equal to 0. How do you solve something like that? What would be my next step? Arc sine. Yes, do arc sine or inverse sine. So that I end up with 2x is equal to the inverse sine of 0. So what is the inverse sine of 0? 0. What else? 0 pi, 2 pi, 3 pi, comma, dot, 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 right? Okay, so to finish this out, I would divide by 2, and I would get x is equal to 0, comma, pi over 2, comma, pi, comma, 3 pi over 2, so on and so forth. What I need to figure out here, of course, those are all numbers where g double prime is 0, and between each of those numbers, presumably g double prime would be positive or negative. What I need to do here is start to focus in on my two numbers, my 5 pi over 8 to 2.1, do they fit within any of those intervals? Do they both fit within from like 0 to pi over 2 or pi over 2 to pi? Like where do they fit? Pi over 2 to pi? Okay, so my two numbers right here, they fit between those two endpoints where g double prime is 0. So all I have to really do here is figure out, okay, between pi over 2 and pi, is g double prime positive or negative? That whole interval would then apply to my interval, and I'm good. What might be a good test value or a way to figure this out? Pi over 4? Yeah, I think that makes sense. So, it's not in between. How about 3 pi over 4? There we go. That would be a better one. Yes. So g double prime of 3 pi over 4 is equal to negative 4. Ooh, I'll just keep writing. It'll eventually, hopefully, come back.
Algebra 1.
Aw.
Who is that? Who is that? Come on.
This announcement is for.
Guys, sit up, please. Sit up. I really think the reason why this is important is, like I said, where we're headed. So if you look at these two notations for the derivative, quick little pop quiz here. Who came up with that? Leibniz. You started it off, right? Who came up with that? Newton. Yeah, Newton didn't. You guys know that Newton's original notation wasn't prime? It was like a dot.
F dot of X.
It was F dot. Okay, I'm not kidding.
Ooh. So would you just have like a stack of dots?
I suppose, yeah.
That was
Second, third derivative.
That'd be kind of fun. You can make little like flowers on there. Get a fifth level.
But it kind of like morphed into like an apostrophe, right? The prime thing.
Well,
So
I guess
they're like, I don't have a key for that. Yeah. Anyways,
if you're a weather forecaster, do you have a key for Fahrenheit?
there's one.
A degree key?
Hey guys, let's finish up well. Listen up, please. So these two notations, they mean the same thing. They're both the derivative of y with respect to x. If you multiply both sides by dx, you end up with something like this. Dy is equal to f prime of x dx. And so we would refer to dy as the differential of y, dx would be the differential of x. Where this comes into play then is when we start finding antiderivatives. I'll just give you a brief preview of that. An antiderivative or an indefinite integral, it reverses a differential is what it really reverses. So if I were to do an antiderivative of both sides, the antiderivative would undo the differential of y into just being y, and it would undo the differential of f prime of x dx into just being f of x. And remember, there's that little symbol that goes on the end of this. Plus c, yep, because there could be some unknown constant out there. Anyways, this is all next unit kind of stuff here. But dy dx equaling f prime of x leads us to this idea of the differential, which will just be a nice springboard into our next unit, if that makes sense. So I think what I'm going to do here, I'm not going to be quizzing you on any applications of just differentials. They're essentially just tangent line equations. You guys have worked hard. You've had a good couple of weeks. I think 5 minutes early is good on a Friday. So why don't you guys head out? See you bright and early on Wednesday, okay?
How early would you recommend that we get here? Or just
You got to know yourself.
okay?